In my introduction, I talk about how there is a national need outlined by like the NRC and other people who put out national standards for kids to improve their critical thinking in science. And a lot of the recommendations I found in literature propose using hands-on learning activities like inquiry labs to help students develop those critical thinking skills. I also go into great detail about the difference between a traditional lab report, where there's something called directed inquiry, where the teacher supplies how to do the procedure and students follow a very specific procedure, and analysis where they don't have to do as much of the creating as part of it. How inquiry labs allow students a little bit more freedom, which is a little bit of an anxious experience for them, but it ended up being really beneficial to their learning abilities. And then I talked about in my literature review how to measure critical thinking, and I really went into the literature to try and find the best ways to do that. I focused on using the science writing heuristic mostly because I had met one of the professors who was on a cohort of people researching it at an AP conference. His name was Tom Grebo, and so I was very excited to meet him, and I was really inspired, and I had been working the last 3 years that I've been teaching AP chemistry to make this better, and I was so glad to be able to see if it actually works with other kids other than my AP. So my research question says, how does using the science writing heuristic lab method influence student critical thinking ability in comparison to traditional verification labs? In my lit review, the first third of it, I focused on students writing to learn. I know we all learn this in our credential programs that kids should be writing in every single class, and a lot of my colleagues are like, but don't we teach mostly math in chemistry and physics? I'm like, no, actually, I think there's a lot of learning to be had in writing. Some of the literature that I found suggested that students don't necessarily put their whole heart and soul to learning a concept in a lab if there's no direct writing assignment that they have to do afterwards to prove that they learned something. So as I'll talk about later, I really increased my student engagement using lab reports in my class. I also tried to look at different ways to improve student writing in general so they could demonstrate their critical thinking during lab. Some of the literature suggested using a checklist or a rubric so that kids knew what was expected of them, and describing how they should be talking to someone. If they were supposed to talk to a peer, were they supposed to write as if they were writing to me, or if they were writing to like a small child. It's just like the more clear that you are with your expectations, the better product the children will produce. And then finally, in my lit review, I talk about the science writing heuristic. Been using the word heuristic, should probably explain that because I had to look it up myself several times. Heuristic is just a method or kind of like an algorithm, a way that you do things that produces a good result at the end of the process each time. So it's a way of doing lab. In the science writing heuristic, just to be clear about the differences between the guided inquiry experience and the demonstrated inquiry experience, which is the traditional one. Science writing heuristic asks the kids to explore the topics on their own, basically without a lab lecture. Have kids look up videos on how to use equipment and write about things during their pre-lab activities. Students look at materials and play with it before doing the inquiry, write their own procedures, and analyze data in groups instead of having teacher-directed instruction. The traditional demonstrated inquiry labs are where the teacher lectures on the lab topics and procedures. The teacher provides a written or an oral procedure or both together, which is what I did. And the teacher provides sample calculations and really walks the kids how to analyze their data. Just wanted to include this quote really quick from one of the main papers that I used to base my rubric for my lab reports. Critical thinking, as defined in my paper, is going to be the intellectually disciplined process of actively and skillfully conceptualizing, applying, analyzing, synthesizing, or evaluating information In its exemplary form, it is based on universal intellectual values that transcend subject matter divisions, clarity, accuracy, precision, consistency, relevance, sound evidence, good reasons, depth, breadth, and fairness. I thought it was like a really mouthful, but it really encompasses what we're trying to get at, because I feel like critical thinking is a little bit of an abstract concept for most people. All right, then one of my studies that I have in my lit review is by Han, Greenbow, and one other author that's slipping my mind at the moment, and they used the science writing heuristic in 3 different experiments on small groups, which is why I wanted to expand on their idea. They used 10 kids per group and studied their lab reports as time went on. They studied the difference between 2 first-year level courses with freshmen in college, and then they studied using a 4th-year traditional instruction. So they tried to show the comparison not only between the same age students, but also what about the older chemistry majors? Could they also make progress? And from their data, they showed that their group that had a science writing heuristic instruction, that they improved their scores on a critical thinking rubric that I also used in my study. So I use this as the basis and inspiration for my own study. The methodologies that I used to measure the critical thinking were a lab report, a conclusion, discussion of theory, and error analysis that the kids wrote, and all of my students wrote. I had 4 classes of kids involved in this study, all honors chemistry students throughout the day. And the rubric is very specific. It had 6 areas where we would measure critical thinking based on how they were organizing their lab report, how many in-text citations or references did they use from their data or from things that they looked up online or in textbooks, measured relevance of the content they chose to talk about, the correctness of the content they chose, and how they ended up preparing the report. Did it look professional at the end? So there are a lot of different areas that we're looking at in the lab reports. I also used post-lab question scores where I presented a similar scenario to the lab, and the students had to answer a series of questions about the lab using the same skills they should have gained during the lab. And the 3rd set of data was their multiple choice test scores through this semester. So I report the beginning scores and the end scores. Data from, which looks really exciting, from the lab reports showed that, and I don't know how many of you are friends with statistics, but when there's a p-value of smaller than 0.05, I believe, yes, and that means it's statistically significant, whatever 2 groups you're comparing. And I had statistically significant results for all of my comparisons. I compared my treatment group's beginning and ending score, and theirs was a significant growth, and then my treatment group to control group, both beginning and end, the treatment group, the one that received the SWH intervention, they had higher scores throughout the entire experience and even higher scores at the end because their growth was also significant. It's a little bit easier to see without the numbers everywhere. On this chart, it's scaled from 6 to 18 because those were the minimum and maximum scores on this rubric, which I'll talk about in the limitations. So you can see how both groups grew, but the treatment group maintains higher scores throughout the entire experiment and ends up having a much higher average at the end. My post-lab questions were not statistically significant, and I'll talk about a little bit more why, but I believe it's because I didn't ask enough questions. There were only about 5 to 7 points on each assignment. I think if I were going to do this again, I would have more questions so that I could get some better numbers. And the multiple choice test scores, a little hard to see in this graph, this table, but there was a significant amount of growth for the treatment group, but not the control group. It's a little bit easier to see here. There's significant growth for my treatment group, scaled from 0 to 100%, but the control group did not show as much growth. In fact, it was not statistically significant at all. Just the treatment group showed a growth in the multiple choice test scores. So just to remind you guys what my question is before I start talking about the real analysis of my data, how does using the science writing heuristic lab method influence student critical thinking ability in comparison to traditional verification labs? In my lab report rubric, all of my students show growth. The treatment group maintains a higher average the entire time, and the treatment group girls, surprisingly, actually outperformed my boys on every occasion. The weird thing in the data, wasn't looking for it, was not part of my initial research question, but I noticed that as I was coding all of the notebooks, they tended to get higher scores. So that might be an interesting thing for the future to talk about. My post-lab questions did not have statistically significant data. Probably, my best guess is there's not very many points per assignment. I also had much harder lab questions by the end of the semester, so there might have been a discrepancy in the difficulty of the questions. And my multiple choice test scores were significant, so it's 2 out of 3 for me. Anecdotal comment about girls in science. I really think that it's possible that including this type of writing assignment where girls feel very successful at may actually change how they feel about science class. I have more seniors this year than ever telling me that they're going into science majors. Biochemistry, chemistry, pre-med, like so many more than usual. Usually I have maybe 3 girls tell me this by the end of the year, but most of them go into whatever other field they're interested in. We have a very inspiring physics teacher at school, so there are a lot of people who would go through like mechanical engineering who are interested in that, but for some reason there's a lot more chem majors this year. Just to talk about things that are limitations in my study, the rubric that I use, I borrowed from literature because I didn't want to have to create my own. It had a 1 through 3 scoring scale in each section, and I really feel like it would have benefited from a 1 through 4. Some of my students in the beginning had empty sections, or they didn't actually do the assignment. I felt like that deserved a lower score than what I ended up scoring. And then some students really excelled, and so I wanted to give them more than a 3. So I felt like I really wanted to change how the rubric could have gone for there, and I would be interested to see what that would do for that. Also, I coded this all myself. I don't recommend people use that many students in this study ever again. It took me 20 hours both times I did it, so I had to steal the kids' notebooks for like 2 weeks and work on it after school for hours and hours. It was awful. So maybe a divide and conquer kind of project where 2 people work on it, or something else, like smaller group of kids. That was nuts. My student sample composition is unique. I have all honors chemistry students, and there was a little bit of unexpected scheduling. I was hoping to have 2 control groups. I ended up with 1 because I wanted to split my periods from before lunch and after lunch, but my administrators moved one of my after lunch periods earlier in the day, and that was kind of weird, but I just went with the flow. Duration of study is always something that we talk about for limitations. We could always do it for an entire year and try and see the results, and that would be way more interesting. And my demographics at my school, though we're in burbs, we do have about 27% free and reduced lunch at my site, and I would say the constituents are about half like identified as Hispanic or Latino, and about half white. So that's not everyone's demographics. I know this works for mine, but it may not work for everyone. My recommendations to teachers are that when you do labs, you need to include a writing component. It's really, really essential for kids to care about the lab. I saw way more engagement in my inquiry groups where like, I need to write down every piece of data because it might be important later. They were just far more attentive in lab, asking great questions during lab, and much more interactive with each other as well. So I really, really think that everyone should do lab reports. You don't have to do 50 million, but just try to include them in your course. And also, I think it's very important to let kids practice designing their own labs. I really think this inquiry portion helped my kids really think about the problem they were trying to solve. And I really think it helps them. My data supports it too. I mean, I had 2 areas that were statistically significant in kind of a remarkable way. Side note, it's very frustrating for students when they try this. They feel like they're not doing anything right, but it shows up in their lab reports that they do know what they're doing, and it shows up in their tests. So don't listen to their whining. Further research, just as a suggestion for myself to look into stuff, and for anyone else who's curious, does an increase in writing in science classes change girls' interest toward chemistry or physics or other types of sciences traditionally boy-dominated? Does inquiry work better with older students versus the high school range? Because that study that I had originally read about was with college kids, and I think this worked really well with my juniors and seniors. And I definitely think you should make your own rubric with a little bit more leeway for adding more variation in coding. I definitely think that would have been better. Questions?
Did you design the lessons yourself? Meaning, like, did you self-guide them to having them build their own inquiry question, or did you have like a book or something?
Great question. There's like 4 or 5 different types of inquiry that are described in the literature. The one that you're talking about is open inquiry. I actually don't suggest that for high school kids. I don't think they have enough background knowledge. So I provided the guiding question, and I let them research the topic beforehand. They wrote like 2 or 3 paragraphs based on what the concepts were going to be. I gave them a list of 3 things. I'm like, you guys need to figure out what this stuff is, write about it on Google Forms, and then I looked at that to make sure they were understanding the concept. The next day, they went to the lab and they looked at all the materials and tried to figure out how those materials could help them answer the question. So there was definitely a little guidance, not complete freedom for teenagers. Chemicals, scary, but they were allowed to design their procedures, and I kind of let them squirt with the data analysis. Yes.
So how many labs did you do?
During the study, 4.
4. And each lab took how long?
3 to 4 days.
3 to 4 days?
Yeah.
And then how long did you take grade?
Forever.
My question is that it sounds really powerful, but
Yes.
for practical purpose as a teacher,
For practical, I definitely recommend using some form of like peer editing, or I made rubrics that were really easy to follow, like checkoffs, and I honestly had my TAs help me with like the student grading portion. I coded everything myself in the study, but my student services definitely helped me with the grading.
And were you able to get through content?
Yeah.
I mean, the same time.
Absolutely.
Mhm.
What I found is that they had a better understanding of things. So like one of the labs I used for stoichiometry, and after doing that lab, I never had to talk to them about stoichiometry again, because they figured out how to do it, and they really owned it. And so I never had to go back and be like, oh, here's how we do this again, guys.
One more question. So
Yeah,
with stoichiometry, where did you place the lab? Beginning, middle, end of it?
Oh, great
Was it
question.
culminating
I
activity?
do like these little lab activities throughout my unit, and I did the inquiry ones at the end when they had a lot of content knowledge. It was more of an extension activity before exams. Really good question. Yes.
Okay, I want to go back to the finding that there was no significant result between the lab question and the
Yeah.
lab question. I think that's actually a really interesting finding.
Yeah.
I mean, if you look at the reasons people do traditional labs, they think that students won't get it if they don't tell them exactly what to do,
Right.
right? But you're showing that, in fact, they can design their own experiment and learn everything the same, just as well as the traditional lab.
That's
But I think
true.
that's really neat,
I think so too.
though not significant.
Now,
I felt the
Catherine,
same way.
Catherine, you understand the significance of what he's pointing out, though? That when you present it, that is something of significance. And so
just
No,
not
you're
statistically significant.
Right, it's not statistically, in other words, but there was no discrepancy in it. There was no, where they received less, they didn't learn as much. No, they were right on
Right on par,
with the
yeah.
traditional, that kind of thing.
Yeah, they almost have
What
the
a good
same
point.
averages on their post-lab scores. And I think they need to add like an extra 30 minutes in one period to allow them to do those in class, because I had a lot of kids living in empty, and I think it messed with my data. So I think they were just like, oh my god, I'm done with the discussion. I'm so eager.
Okay, one more question. Anybody have a last one for her? Well, fantastic. Thank you.